Okay, so we're going to spend a little more time with the shell method. All right, shell method is a little bit different from the disc or the washer because we revolve around the y-axis instead of the x. Unit circle and underdog. Interesting. Okay, so I'm going to just pick some sort of crazy function, and I decided, hey, how about having f of x equal cosine of x squared? Notice the x is being squared, not the cosine function. And I'm going to go between 0 and root 2 pi over 2. Now, I can't steal an image off the internet because I just made this up off the top of my head. So instead, I'll say, hey, graphing utility, so graphing calculator. If you like graphing calculators, I like Desmos. Now, if you're looking and say, wait a minute here, I thought the interval was 0, comma, root 2 pi over 2. Yeah, it is. But to make that blue dot show up where I want it to show up, I have to put it in as an x comma y point, right? So for the interval, yeah, we're going to start at 0 on the left, and we'll move to the right until we hit that crazy root 2 pi over 2. But to get that dot in the right spot, I have to put it in as an x comma y. And so that's the region that I'm going to play with. And I'm going to revolve that around the y-axis. And again, since I didn't steal this off the internet, I don't have a really good copy and paste. So instead I'm thinking, well, what would the shape look like? And so I went looking for images of a gumdrop, and I kind of squished it and flattened it out. And so, okay, not a perfect fit, but you kind of get the idea. But to actually do all the work here, all I really need is I need to know that function. I need to know my interval. And the only reason why I want to make a quick graph of it is I want to make sure that there's something really weird not happening, right? I want to make sure it's like, okay, does it look like I had a normal region? Sure enough, we got a normal region. I didn't put any trap or surprise in here. And so, of course, the volume, when we revolve it around the y-axis, we have to use the shell method. So it'll be the integral from a to b, 2 pi times x times the function of x times dx. Well, we're going to start at 0 on the left end. We'll integrate to the right end at root 2 pi over 2. The 2 pi I keep. The x I keep. The function of x, well, that's easy. That's cosine of x squared. And then there's the dx. And you're like, well, just a minute here. The last time you kept putting that 2 pi out in front. How come you didn't put that 2 pi out in front? Hang on for just a second. Because who's going to come save the day for us? Speed of lightning, That's right, a u substitution. I'm going to have u equal x squared. So when I take the derivative of u with respect to x, I end up with du dx equals 2x. Right? And of course, if I multiply both sides by dx, I get du equals 2x dx. And so that's why I wanted that 2 to sit there, right? The x squared is taken care of by the u. The 2, the x, and the dx is taken care of by du. So that pi symbol, I can either leave it where it is or I can move it out in front on the next step, which is what I think I'm going to do. Ooh, we changed variables. I need to change the limits of integration. So if u equals x squared, well, what's 0 squared? 0. That won't change. Okay, so that one's a piece of cake. Now, if u equals, oh my goodness, x squared, so I got to plug in square root of 2 pi over 2 and square that. Well, numerator's not so bad. Square root and square cancel out. Denominator, 2 times 2 is 4. That looks a little bit better. Oh, hey, 2 over 4, that's 1/2, pi over 2. So pi over 2 looks a lot better. Right? So what do we have? Well, I'm going to put the pi out in front. My new limits of integration are 0 and pi over 2. And now I just have cosine of u du. Say, okay, now I know the derivative of sine is cosine. So if I go the opposite direction, if I want to integrate cosine, I will get sine. And of course, I don't need to put a plus c because we have a definite integral. So instead, I need to plug in the pi over 2, evaluate that. Got to plug in 0, evaluate that, do some subtraction. Of course, sine of pi over 2, the unit circle. That's right, the very tip top of the unit circle, sine of pi over 2, sine would be positive 1. Sine of 0, sine has a value of 0 and we're at 0. And so let me see if I can do this correctly. I'm pretty sure that 1 minus 0 is 1, and then pi times 1 is going to be pi, and we have an answer. Pi cubic units. Dun, 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 dun. So short and sweet. All right, no new integration concept. Just going to have you practice the shell method and maybe throw some old friends in just for good measure. So short video. Try to get some success with the assignment, please.